Continuing with Chapter 1 on equations and inequalities, we're still on Section 1.2, quadratic equations, and now we're going to look at our last method for solving quadratic equations, the quadratic formula. So consider the quadratic equation ax squared plus bx plus c equals 0. We know that's the standard form, where a is not 0. The solution to the equation can be found using the quadratic formula. Now, you probably already know this, but you definitely need to know this if you don't. So what is it? If you know it, go ahead and write it. Don't wait for me, just to check to see if you remember. X equals, right? Negative b plus or minus, there's that two solutions, the square root of b squared minus 4 times a times c all over 2a, right? The quantity b squared minus 4 times a times c is called the discriminant of the quadratic equation because its value tells us whether the equation has real solutions and how many to expect. So if b squared minus 4ac is a positive number, it's greater than 0, we expect two unequal real solutions. If b squared minus 4ac is 0, that's when we get that repeated real solution, or as I mentioned before, a multiplicity of 2. Like we saw that before. That would be when b squared. Notice, if this is 0, then you don't have plus or minus. You just have negative b over 2a. That's it. If b squared minus 4ac is negative, less than 0, there is no real solution, no real number solution. So here's our procedure to solve a quadratic equation. First, put it in standard form, ax squared plus bx plus c equals 0, and then identify a, b, and c. Don't do that until it's in standard form because you want to get the signs correct. Then evaluate the discriminant, the b squared minus 4ac. If it's negative, the equation has no real solution. If it's 0, the equation has one real solution, a repeated root, and if the discriminant is positive, the equation has two unequal real solutions. Now it's just repeating what we saw above, but this is so important. We want to make sure we get it. Okay, let's look at example 4a. In example 4a, we need to, in my opinion, is clear out those fractions. I would much rather not have a's and b's and c's that are fractions to plug into this equation. There's only one common denominator, right? The common denominator is 5 because they're all 5. So the first thing I would do is multiply both sides of this equation by 5. So 5 times 2/5 x squared minus 4/5 x, and 5 times the negative 1/5. So now I have 2x squared minus 4x equals negative 1, but that's not in standard form. I need to add 1 to both sides. 2x squared minus 4x plus 1 equals 0. Okay, now it's in standard form. Now let's follow these steps. Let's identify a, b, and c. A is 2, b is negative 4, c is 1. And let's evaluate the discriminant. B squared minus 4ac would be negative 4 squared minus 4 times 2 times 1. Negative 4 squared is positive 16. And negative minus 4 times 2 times 1, that'd be 8. So we've got 16 minus 8, which is 8. That's a what? It's positive, so we're going to have two unequal real solutions, right? Okay, so that means continue on. All right, so x is equal to negative b. B was negative 4, so negative, negative, be careful with that. Plus or minus the square root. I don't need to recalculate. That's 8. B squared minus 4ac all over 2a, 2 times 2. So negative, negative 4, that makes that 4. Plus or minus, the square root of 8 can be simplified. That's 4 times 2, square root of 4 is 2, so that's 2 square roots of 2 all over 4. So we're seeing we're getting those two unequal real solutions. It's irrational because it's got a square root, but it's real. Okay, so now, but that's not simplified because I have a common factor in the top, I can pull a 2 out, 2 plus or minus the square root of 2, because I see I have a 2 in the bottom. We can cancel common factors. Resist the urge to cancel these 4's. You cannot cancel terms. 4 is a term. Terms are separated by plus or minus. We cancel things that are multiplied. Now I have a 2 and a 2 that are factors. Those may be canceled, leaving behind 2 plus or minus the square root of 2 over 2. So in my brackets, I might even write it like that, 2 plus or minus the square root of 2 all over 2. That's two different answers, right? I don't want to calculate it because then I'll have a bunch of decimals I'll have to round. So I'm leaving it in accurate form here. Okay, let's go through those steps one more time. Here we have our standard form. We don't have any fractions, but we do need to identify A, B, and C. And now we did that. Let's evaluate B squared minus 4 times A times C. Negative 2 squared minus 4 times 1. So negative 2 squared would be positive 4, and 4 times 4 is 16, times 1 is 16. So we get negative 12. So what does that tell us? If B squared minus 4AC is less than 0, there is no real solution. What we said here, if the discriminant is negative, no real solution. No real solution. Or as we've seen before, or you may see empty brackets indicating there's nothing in there.